This video covers the review for section 13.1, sequences in series. Number 1, write out the first 5 terms of the sequence. The first term in the sequence is found by setting n equal to 1. We call this A1, or the first term. Where we see n, we plug in 1. 2 times 1 over 2 times 1 plus 3. That's 2 over 2 times 1 is 2 plus 3 is 5. So the first term in the sequence is 2/5. The second term in the sequence is found by setting n equal to 2. 2 times 2 over 2 times 2 plus 3. 2 times 2 is 4. 2 times 2 is 4 plus 3 is 7, giving us 4/7. The third term in the sequence is found by setting n equal to 3. A sub 3 is 2 times 3 over 2 times 3 plus 3, which is 6/9. We should reduce that down to 2/3. So we say the third term in the sequence is 2/3. The fourth term in the sequence is found by setting n equal to 4. And we would get A sub 4 is 2 times 4 divided by 2 times 4 plus 3. This is 8 over 8 plus 3, which is 11. So the fourth term in the sequence is 8/11. The fifth term in the sequence is found by setting n equal to 5. That's 2 times 5 over 2 times 5 plus 3. That's 10 over 10 plus 3, which is 13. And those are the first 5 terms of the sequence. In letter B, the first 5 terms of the sequence, the first term is found by setting n equal to 1. We have -1 to the first power divided by 1 plus 1. -1 to the first power is -1, and 1 plus 1 is 2. So the first term in the sequence is -1/2. The second term in the sequence is found by setting n equal to 2, giving us A sub 2 as -1 squared over 2 plus 1. -1 squared is 1. 2 plus 1 is 3. Second term is 1/3. The third term in the sequence is found by setting n equal to 3, giving us A sub 3 is -1 cubed divided by 3 plus 1. -1 cubed is -1. 3 plus 1 is 4. The fourth term in the sequence is found by setting n equal to 4, giving us A sub 4 is -1 to the fourth over 4 plus 1. That's +1 over 5. And the fifth term in the sequence is found by setting n equal to 5, giving us A5 is -1 to the fifth divided by 5 plus 1. -1 to the fifth is -1, and 5 plus 1 is 6. Fifth term is -1/6. So we recognize the alternating negative, positive, negative, positive, negative is coming from the -1 to the end. The n plus 1 is the fact that the denominators go 2, 3, 4, 5, 6. Because when we go the other way, finding a formula, we need to recognize patterns like that. Letter A, 5 to 9 to 13 to 17. We see that every time we're adding 4. So that's like the slope in y equals mx plus b. It's just that with sequences, we no longer use x's, we use n. And we use a sub n for y. So the slope being 4, the b is the y-intercept. That would be when x is 0. So if we're adding 4 moving to the right, we subtract 4 going back. So this would be a sub n is 4n plus 1. We check that by saying, well, if n is 4, a sub 4 should be 17. A sub 4 is 4 times 4 plus 1, which is 16 plus 1, which is 17. So we get those kinds of answers if we're adding the same number every step. Letter B has two things happening. We have alternating signs. And we recognize that the odd term and the even terms, they have opposite signs, but the even terms are negative here. That is achieved by using -1 to some power. It's either -1 to the n or -1 to the n plus 1. And we recognize from 1b that here the odd terms are negative. Because the first, the third, and the fifth are negative, and that was to the n power. To make the even terms negative, you use the n plus 1. Because plugging in 1 gives you -1 to the 1 plus 1, which is -1 squared, which is +1. And then the next part of it, we're doubling each step. We're multiplying by 2. The first one is 2 to the first. The second one is 2 squared. The third one is 2 cubed. So the numbers are times 2 to the n. And if I plug in n equal to 1, that's times 2 to the first, which gives us +1 times 2, or just 2. Checking A2 would be -1 to the 2 plus 1, 2 to the n, or 2 squared, will be -1 to the third times 4, or -4. And so we say a sub n is -1 to the n plus 1 times 2 to the n. To C, we see again alternating between pluses and minuses, but this time the odd terms are negative. For this one, we use -1 to the nth. And now that each term, 1, 4, 9, 16, 25, we recognize each of those as perfect squares, or 4 is 2 squared, 9 is 3 squared, 16 is 4 squared. So each of those are the number of the term squared. 9 is 3 squared, it's in the third spot. 16 is 4 squared, it's in the fourth spot. So -1 to the n times n squared. Those are all sequences. And then when we add up the terms of a sequence, we call it a series or the sum using summation notation. Sigma means add. Add up the first through the fourth terms. We're going to set I equal to 1, and the first term is 3 times 1 minus 5. And we're going to add to that the second term by setting I equal to 2. 3 times 2 minus 5. I equals 3. 3 times 3 minus 5. I equals 4. 3 times 4 minus 5. So the first term is 3 times 1 minus 5, which is negative 2. Second term is 6 minus 5, which is 1. Third term is 9 minus 5, which is 4. Fourth term is 12 minus 5, which is 7. Adding those up, 7 plus 4 is 11. 12 minus 2 is 10. That sum becomes 10. Letter B, this time we're adding up 1 through 5. The first through the fifth terms. The first one is I equal to 1. We've got 1 squared minus 3. We add the second term, 2 squared minus 3. The third term, 3 squared minus 3. The fourth term is 4 squared minus 3. 5 is 5 squared minus 3. 1 squared minus 3 is negative 2. 2 squared is 4 minus 3 is 1. 3 squared is 9 minus 3 is 6. 4 squared is 16 minus 3 is 13. And 5 squared is 25 minus 3, which is 22. That's 35 plus 6 is 41 plus 1 is 42 plus negative 2 is 40. And then going the other way, write each sum in summation notation. Letter A, we've got 1 squared plus 2 squared plus 3 squared plus all the way up to 7 squared. The first term, 1 squared. The second term, 2 squared. The third term, 3 squared. All the way up to 7 squared, so we're adding up 7 terms. We'll add up all the terms between I equal to 1 and 7. And the first term is 1 squared, second term is 2 squared, so we are squaring each term. Now, if you're wondering about the shift from n to i's, you could also write this as summation from n equals 1 to 7 of n squared. The letter used does not matter. Letter B. We're adding 1 to 3 to 5 to 7 to 9, 2 to 4 to 8 to 16 to 32. The terms of the sequence. The numerators are all the odd numbers, 1, 3, 5, 7, 9. Adding 2 each step, so it's a 2n, and the 0th term before that would be a minus 1. So the numerators are all 2n minus 1s. The denominators, they're adding 2 each step, and the 0th term on that one would be a 0, so they're all 2n's. 2n minus 1 over 2n. And we've gone from 1 to 3 to 5 to 7 to 9, 2 to 4 to 8. Sorry, those denominators are not being multiplied by 2. Those are powers of 2. It went 2 times 2 is 4, 2 times 4 is 8, 2 times 8 is 16, and 2 times 16 is 32. Those are 2 to the power of n. And we've gone from 1, 2, 3, 4, up to 5. So we go from n equals 1 to 5. And the last one, letter C. The terms of the sequence. The first term has a 1 on top and a 2 on the bottom. The second term has a 2 on top and a 3 on the bottom. So the denominator is always 1 more than the numerator. 1, 2, 3, 4, 5, 6, 7, 8, all up to 13, and then 2, 3, 4, all the way up to 14. So the numerator is the same as the position, or the first term, second term, and so on. And then the denominator is 1 more than the position, so n plus 1. We've gone from 1 to 13 on top and 2 to 14 on the bottom. That is a total of 13 terms. So we sum up from 1 to 13 of n over n plus 1. And this concludes the video for the review for section 13.1.